All right, this video we're going to be going over centroids and moments of inertia. So first things first, let's talk about centroids. So the centroid of an object is going to be kind of its balancing point. If you were to balance some object on your finger, it would be where it would perfectly balance on your finger, that point where you would have to hold the object where you could balance it. All right, so just some things to know about centroids. For common shapes, for say a square, centroid's going to be right in the middle on both sides of that. So that's going to be that side length divided by 2, side length divided by 2, and same goes for over here. Now, same goes for a rectangle. Length of the bottom divided by 2, length of the bottom divided by 2, and then it's also going to be length of the side divided by 2, length of the side divided by 2. Now for a triangle, we're going to get a centroid about right here, where this is 2/3 of the length, and this is 1/3 of the length, and the same goes over on this flat side as well. So this will be 2/3 L, and this is 1/3 L. So you always start at the pointy end, and then you move down 2/3, or you start at a flat end and move up 1/3, and that will get you to your centroid. Again, pointy side over 2/3, or flat side over 1/3. All right, so you can actually take an object that is a combination of 2 or more shapes and sort of add them together to get a centroid. So your centroid is going to be equal to x bar, y bar, where you define some datum. Say our datum was this bottom corner right here. Then you would move over x bar and then up y bar to get to the centroid. All right. So again, x bar, y bar, and this one here would be x bar, and y bar would be there. All right. So if we were going to find this, we would have the equation of x bar being the sum of x tilde times its individual area for each shape divided by the sum of all the areas of the shapes. All right. And same goes for y bar, except you're going to have y tilde times area on top and then some areas on the bottom. Now this x tilde and y tilde thing that's going on, that's going to be the distance from your datum to the centroid of that shape. So this would be x tilde for the triangle, and this would be x tilde for the square right there. All right, so if we just add some dimensions to this, we'll say this side right here is 2 feet. This is 2 feet. And we'll say from here to here is also going to be 2 feet, and then here to here, yes, like I said above, is 2 feet. All right, so let's go ahead and find our x bar and our y bar. All right, so x bar is going to be equal to our x tilde for the triangle times area of the triangle plus x tilde of the square times area of the square, all divided by area of the triangle plus area of the square. Okay? So x tilde for the triangle, again, is going to be from our datum here that we've defined over to the centroid of that shape that we're looking at. So x tilde for this is going to be 2/3 of the length of the triangle. So 2/3 times 2. And then times the area of the triangle is going to be 1/2 base times height. All right, now we're going to do the same thing, but for the square. So x tilde for the square is going to be from our datum over to the centroid of our square. So we know from the edge of the square over to there is going to be 1 foot because it's just this side divided by 2. So we can add this 1 foot plus the 2 feet to get back to our datum. So we're going to get 3, and then times the area of our square is just 2 times 2. All divided by area of the triangle plus area of the square. You plug that all into your calculator and you're going to get 2.44 feet for the centroid of that shape. For the x coordinate of the centroid of that shape. So we want to find the y coordinate. We're going to do the same thing, but we're just going to replace our x tildes with our y tildes. So our y tilde is going to be 1/3 of 2 is this distance here times the area, 1/2 base times height, plus x tilde of 1 for our square times base times height, all over our areas, 1/2 base times height plus base times height. And if you plug that into a calculator, you're going to get 0.89 feet. All right, so our centroid for this entire object is we're going to start at our datum. We're going to go over 2.44 feet. Let's do that in a different color. So about here. And then we're going to go up 0.89 feet, so just below halfway. And that would be our datum, or our centroid, for this shape, or this object. All right, so go ahead and try on your own something that looks a little bit like this. So if this is our datum here at 0, 0, you come up here and we go down, over, down. All right, so we're going to have also a hole in this shape where this is going to be, boom. All right, so if we were to extend these down for dimensions, and All right, so okay, let's say this is 1, 3, 4, 6, and 9, and 1, 3, 6, 9. All right, and so you're going to try to find the centroid of the shaded area. So not including that hole there, that square hole in the middle of that shape. All right. So the key here is going to be to split this into different smaller shapes that you know the centroid of. All right. So just to get you started, you could split it here. All right, so you'd have this hole as one shape, this rectangle as another shape. And then you can actually cut it here. So you can get this triangle as a third shape, and then this rectangle down here as a fourth shape. All right, so you're gonna have to do a little bit extra work, but I think you'll be able to get it. So pause the video, work this out, and then check your solution with the PDF. This will be number 1. All right. So let's talk about moments of inertia. All right, so some things you should know about the moment of inertia is we have basic equations that you can find moments of inertia for common shapes. So rectangle or squares, we can get an I of BH cubed over 12. And for a triangle, we'll get a moment of inertia of BH cubed over 36. All right. Now, a couple things to know about these is that these equations are for the moment of inertia about the object's own centroid. All right. And also that B is the base, but that is also the side that is parallel to the axis you are taking the moment of inertia about. So if you were taking the moment of inertia about the x-axis with the origin going through the centroid of this square right here, then your base would be this right here because it's parallel to the x-axis. And so your height would be perpendicular. So it would be this distance here. But if you were taking about the y-axis, then the base would be here because this line is parallel to your y-axis, all right? And then the height would be here because it's perpendicular to your y-axis. Same goes for the triangle as well. All right, so again, just like we did with the centroid, you can just take shapes, break them up, and then add all of their moment of inertias together. But one thing you do have to do is you're going to have to be able to move these axes around. So if This equation here would find the moment of inertia about this axis, but if you wanted it about this axis, then you'd have to move your axis by using the parallel axis theorem. All right, which says moment of inertia equals the moment of inertia about that object centroid plus area of that object times distance squared, where d is the distance between current and new axis. So it would be this distance right here. If you were moving it from here to here, you would just do the distance between them squared. All right, so let's go ahead and do an example of this. If we've got these are our axes here. We've got this object. Let's say that it's 5 feet tall, 3 feet wide, and the square that's cut out in the middle is 1 foot by 1 foot. And the dimensions on this side are going to be 1 foot, 1 foot, 3 feet. All right, so we're just going to go ahead and take this one shape at a time. So we're going to find moment of inertia about its own centroid of the overall tall rectangle. So that's going to be BH cubed over 12, where B is parallel to the axis we're taking it about. So let's find IY. All right, so base is going to be parallel to the y-axis. So it's going to be our 5 feet times our height, which will be our 3 feet cubed over 12, which is 11.25 feet to the fourth. And then we can also do that for the square. So BH cubed over 12, 1 times 1 cubed over 12 equals 0.083 feet to the fourth. All right, now let's use the parallel axis theorem to move it to our y-axis. All right, so I for the rectangle is going to be I prime, which was 11.25, plus the area, so 5 times 3, times d squared. So we need the distance between the old and new axis. So we know for this rectangle, our axis goes right down the middle. All right, and it's this BH cubed over 12 is about this axis here, but we need to move it here. So the distance we're looking for is that distance there, which is just going to be 3 divided by 2, so 1.5. And if you plug that into a calculator, you get 45 feet to the fourth. All right, so now we'll do that same thing for the square. 0.083 plus the area, 1 times 1, times distance squared. So we've got this square here, and the 0.083 was about this axis, but we need to move it to this axis. We know that, let's see, miss some dimensions here. This is going to be, boom, boom. So 1 foot, 1 foot, 1 foot. So we know that this distance here is 1 foot. And then we know that this distance here is just half of this distance, so 0.5. So our distance is going to be 1.5 feet squared. So if you plug that into a calculator, you will get 2.33 feet to the fourth. Now to get an I total, you're just going to sum up your I's. However, in this case, because this here is a hole, we're taking away moment of inertia, so we're going to subtract this one from our solid area. All right, so we're going to get 45 minus 2.33, which is 42.67 feet to the fourth. All right, so let's go ahead and give you one to try on your own. All right, so you've got that shape right there, and we're going to try to find the moment of inertia about the x-axis. All right, so go ahead, work that out, check the solution, figure out what you did wrong, let me know if you have any questions, and then go ahead and do the quiz for this section.